So let me introduce to you our first speaker, Yuri Pavlov. He is a postdoctoral researcher at Borisov's Kochubey lab at University of Tübingen. What Yuri is going to present is, I think, very fortunate to us because he's going to provide some evidence that sleep does not facilitate human fear memory consolidation. Also, Yuri shared a preprint with us of a recently accepted paper on the analysis of neural activity during sleep in individuals with severe consciousness disorders. So if you want to learn more, the link is going to be available in the chat. And with that, Yuri, you can share your screen and you can start.
Okay, thank you for the nice introduction. So I'm going to talk about study recently completed where we looked at the central mechanisms of fear memory consolidation and how it relates to sleep. I think most of us know that acquisition of fear memories can lead to chronic mental disorders such as anxiety disorder or post-traumatic stress disorder. And also there is a vast amount of literature showing that sleep actually promotes memory consolidation. But what we don't know, we haven't looked much at the central mechanisms of human fear memory consolidation. I mean, there are some studies using skin conductance and other peripheral measures, but what's happening in the brain is kind of mystery. And we try to address this gap in the following study. The participants came to the lab 3 times, and on one of the day 2 or 3, they participated in a session of fear conditioning, then slept for about 2 hours, and then there was another session of fear conditioning where we paired neutral sounds with an unconditioned stimulus, which was a loud noise. And on the other day, everything was the same except for the intervention part, where the participants were watching silent videos and we controlled that they didn't fall asleep. While all of that was happening, and after each block of fear conditioning, we asked participants to assess the valence and arousal of the sounds they just heard. We also recorded EEG continuously throughout the whole session, and we also recorded finger photoplethysmography during the conditioning sessions before and after the intervention. Let's look at the behavioral results. Here's the valence scores before and after the intervention. Here's the sleep and the control condition, the period of wakefulness, 0, 50, and 100% reinforcement rate, meaning that in the 0% reinforcement rate block, there was no pairing of the conditioned stimulus with any unconditioned stimulus. There was a sequence of neutral sounds and nothing else. We see that the valence scores at the beginning are the same, they're not different. And in the 50% reinforcement rate block, the conditioned stimulus started being paired with unconditioned stimulus, which was the loud noise, or in the case of CS minus, it was just another sound, mildly pleasant sound. We see that here is a significant difference in this 50% reinforcement rate block, and the difference maintained in the last block where the CS and US similar were paired in 100% of cases. After the intervention, the picture was pretty similar, and we didn't see any difference between the sleep and wakefulness condition. But what is more important is EEG that we recorded throughout the session. And we looked at the event-related potentials in response to the neutral, the beginning sound. CS plus here is the sound, there's 0.0 when it was presented, and CS minus is another sound which wasn't paired with unpleasant event. What we found when we averaged all the trials, and there were quite plenty, we found that there is no specific ERP component that can differentiate CS plus and CS minus. There is rather a slow wave occupying all this time window starting from about 220 milliseconds. There is basically a slow wave similar to contingency negative variance CNV slow wave starting at this time point. And we looked at this slow wave, how it develops and how it changes in all our conditions. What we found first, that at the beginning there was no difference between the CS plus and CS minus. Good, but then the difference became significant, and if we average all these conditions, we see quite strong effect of contingency, meaning that the slow wave to CS plus and CS minus was significantly different, and the slow wave to CS plus was larger or more negative, if you like. Here's the same data, but in bar plots. You can see there's no difference at the beginning, and actually there was no difference after the intervention and no significant interaction between the type of intervention and the pre-post comparison. It means that there is no difference between the conditions, between the condition when you spend 2 hours asleep or being awake. But what we found in both of these conditions, that the slow wave became stronger after a period of time. So this reconsolidation of fear, or relearning of fear rather, makes the response stronger. Even though in this first block, it was completely extinguished. And last, we looked at the cardiovascular responses. Here I presented just one of them, HRV and heart rate variability. We couldn't actually look at the event-related changes in heart rate variability because it would require much longer interstimulus intervals, but we could look at the heart rate variability in all these 3 blocks with different reinforcement rate. Surprisingly, there was no difference between them because, yeah, we would expect it that heart rate or heart rate variability would change when you present unconditioned stimulus, this unpleasant stimuli, but it didn't happen. But what happened instead, after the intervention, there was a significant increase in heart rate variability, especially after the wakefulness condition. There was a significant interaction between this pre-post comparison in type of intervention. Why it matters? I think it is an interesting observation. I'm not sure whether we will replicate it, but it may be interested in the context of this kind of works where people look at the heart rate variability and relationship of heart rate variability with emotions, emotional response. And fear, learning fear is also an emotion. We saw, basically what we saw, that if you increase somehow heart rate variability, these changes in heart rate variability doesn't affect fear learning. Okay, let's go to the conclusions. What we found that this long-term conditioning is equally efficient after a period of sleep or wakefulness, and relearning fear increased the slow wave amplitude, but actually we didn't see it on the behavioral level. Conditioning with 50 and 100% reinforcement rate is equally efficient. There's no difference on all three levels. And increase in heart rate variability does not affect peer learning. Thanks for your attention. Let's discuss it.
Okay, thank you very much, Yuri, for a very insightful talk. And it was very interesting to learn about this selective memory consolidation during sleep. So while people are coming up with questions in Q&A panel, I actually have a question myself. So as far as I understood, you presented either neutral stimulus to the participants or unpleasant and negative stimulus and observed the increase in the slow wave amplitude. Have you tried presenting them with some kind of positive or some kind of pleasant stimulus to see how the EEG activity changes during sleep?
What do you mean? We looked at the changes in EEG in this associative learning paradigm in response to the stimulus, which was at the beginning neutral, but became significant. So it's like the definition of
unpleasant,
classical conditioning.
Right?
No, the neutral sound was always neutral, but it was paired with something unpleasant. If you find a stimulus which is pleasant and we can use in our experiments, I will thank you for that. So, but it is extremely difficult in human classical conditioning. You cannot give a person like 60 pieces of chocolate, or because in order to record EEG and get this earpiece, you need many trials, and that's the problem. So now we are looking at the ways how we can actually try to approach this problem, and the only approach we have now is to try to use smells, some pleasant smells, which is also technically very challenging, but I hope it is possible. Anything else is not either habituates really quickly, like this chocolate or something like that, or it's just not pleasant enough. No. There is also a way like a relief, pain relief is also pleasant, but yeah, we don't gonna.
And you don't want to
go in this direction.
Right.
Right. I have a brief question. Like your participants, they slept during 2 hours, right?
Oh yeah, they had a sleep opportunity. So
yeah. Okay. Yes, I was about to ask if the onset of the different sleep stages was similar because like all of them went through conditioning, right? You don't have participants that didn't get to be okay. Yeah, right. Yeah, nice to see those results.
Okay. I think it's actually about the time to move on. So thank you very much, Yuri, again. And
thank you.
Find Yuri's Twitter account in the chat if you want to learn more about his research. And okay.